Hello everyone, you're welcome to my YouTube channel. My name is Precious. Alright, so in this video and new series, we're beginning to look at the concept of equations, which we can also call simple equations. Okay, so this is just the beginning of algebra. You recall that algebra is that mathematical concept that deals with numbers and alphabets. Okay, so instead of writing a number, you can use an alphabet, say X, to represent a number in a mathematical statement, which we call expressions. So we have mathematical expressions or algebraic expressions, which represent mathematical statements. For instance, I can write X plus 5. This is a mathematical expression. Okay, so now, but when it now becomes an equation, is when we now have a mathematical statement that says that two things are equal. In other words, I can say that an equation is a mathematical expression that contains an equality sign. All right, so that's just another way of saying it. So, for instance, I can say that x plus 5 is equal to 0. So, the implication of this is that there is a number which I do not know and I am calling it x that I will add 5 to and I will get 0. So that is what this statement is. Now, meanwhile, a mathematical statement can actually be true or not true. So, in other words, one can say that 2 is equal to 7. This is a mathematical statement. So it can either be true or not true. But for the purpose of our lesson, we will be only considering the true mathematical statement. Okay, so when one says that, say y now minus maybe 3 is equal to say 8. Okay, so what this person is trying to say is that there is a number which he or she does not know, but if you remove 3 from that number, which is subtraction, you are going to get 8. Now, a number is missing, and that's what leads us to solving of an equation. So simply put, that solving an equation simply means looking for the value that is unknown. So if I don't know the value of y and I'm looking for it, so to solve this equation simply means to find the value of y. And to do all of that is very simple. So there are basic things we need to take note of, and one of it is that every mathematical statement that is true is supposed to be balanced. That means whatever you have on the right hand side, which is this way, must be equal to what is on the left hand side. That is what makes the statement true. If not, the statement becomes false. And so what it means is that it compels us that whenever we are to solve a mathematical expression, for instance, what we have, maybe x plus 3 is equal to 10. So to solve this, if I want to do anything to the left hand side, this particular condition requires that I must also do it on the right hand side. That means I can choose to say, let me remove 3 from the left hand side. So I'm going to have 3 minus 3. Now, there is no problem with what I have done on this left hand side if I end up doing it on the right hand side. So as I have removed 3 from the left hand side, I should also remove 3 from the right hand side. And in the process of doing that, 3 minus 3, this will take away this. So I will only have x left. And then on the right hand side, I will have 7. And that's actually the solution to this particular equation. Okay, so now that leads us to the point of what it means now again to solve an equation and how to do it. In other words, to solve an equation, I am writing again x plus 3 equal to 10. Remember that the whole essence is to find the value of x. And to find the value of x means that I want my x to be on one side alone, to stand alone, just as what we achieved here. To achieve that, anything that is mathematically correct that I can do to this equation to ensure that my x stands alone, especially on the left hand side, it can also be on the right, that is allowed. And one of the things you can do is to subtract from both sides, to add to both sides. And when do you subtract? You subtract when you have addition. So you just do the opposite. so that it can remove what you have on this left hand side. If I have minus, for example, x minus 2 is equal to, let's say, 8. So how do I take away negative? I do the opposite. The opposite of minus is plus. And so I'm going to add 2 to both sides in this manner. If I do it this way, that's also not wrong. Okay, so when I do that, my this will take away this, and so I have only x left here, and that's it's equal to 10. So that gives me the solution to this problem. So that is for addition and subtraction. And as we go further, we are going to see multiplication and division. You recall that these are the four basic operations in mathematics. So you have addition, subtraction, division, and then multiplication. So like I said earlier, addition is the reverse of the subtraction, while division is the reverse of the multiplication. In other words, if I have 3 times x is equal to something, let's say 12, and I want to make my x to stand alone, the only way to let this x stand alone is to remove this 3. And to remove the 3, you will need to do the opposite of the operation binding the two of them. The 3 and x are, both of them are bound by multiplication. So of course you know that AB means A times B. Okay, so when you write 3x, it means 3 times x. And so if you want to remove the 3 that is together with x by multiplication, what you would do is the opposite of multiplication, which is division. So for me to remove this 3, all I need to do is to divide both sides by 3. And when I do that, that would have helped me. The 3 here will be cancelled by the 1 down below. And so I have my 3 alone. And so my answer here is now what? 4. Okay, so that's what we are going to be doing. So quickly, let's look at some examples here. The first one here says we should solve the following equations. Remember I said earlier that whenever you are asked to solve equations, what the person is invariably saying is that you should find the value that is missing, the one that is represented with X or any other alphabet. Recall that the variables you're seeing here, I said earlier, are actually numbers that are missing. What it means is that for this number one is asking you what will be added to 3 to get 8, or what will 3 be added to get 8. In the number 2, they are asking what will you subtract 6 from to get 10. And in number 3, they are asking what will you subtract 4 from to get 1, and all of that. So for instance, you know that if I add 5, or if I add 3 to 5, I am going to get 8. That is to say that my x should actually be equal to 5. And so how do you get that 5? That's exactly what I was doing in the previous slide. All you need to do is to find a way to take away this 3 to the other side of the equation. And to do that, to remove that 3, I will only subtract 3, because the reverse of or the opposite of addition is subtraction. So if I do x plus 3 minus 3, I will only come to the right hand side and do the same thing. I will also remove 3. And so that's going to give me this 3 will remove this, because 3 minus 3 will be 0. So I only have x on the left hand side, and on the right hand side I have 8 minus 5, sorry, minus 3 as 5. And that's the solution to this problem. And so let's look at the second example. This is number 1. So for number 2, you can quickly see that you have y minus 6 to be equal to 10. So how do you do this? Remember we said the process is to find a way to make sure that your y is alone. And to do that, I just do the opposite of the operation binding the two of them. And the opposite of minus is plus. So this is going to give me y minus 6. So I'm going to add 6 to this. Now, but on my right hand side, to make sure that I balance this equation, I will also add 6. And so this is going to take away this 6. And so my y alone is actually equal to 16. And you can check this, even this other one. You can check it. Of course, if I replace that x with 5 and add 3 to it, is going to give me 8. And so it makes this particular statement true. And if you check this other one, if you do 16 as your y minus 6, you will definitely get what? 10. That means that this is actually correct. Okay, so now as we progress, one of the things you can also do to ensure that you don't take all of these long processes is the fact that let me look at this number 2 again. I have y minus 6 to be equal to 10. I can actually decide to bring everything I have here standing with y to the other side of the equation. That's also another way of ensuring that my y is alone. And to do that, I want you to take note of this. If your plus crosses equality sign, if I have plus anything, any number positive, whether number or alphabet, crossing equality sign, the sign will change to minus. If minus crosses equality sign, the sign will change to plus. Okay, so take note of that. So if we do that here now, it means that our y will remain alone. Then on the right hand side, you have 10 already. So your 6 now crossing over, remember it is negative. So it's going to become what? Positive. So you will simply get 10 plus 6, which is 16. And that's exactly what we got in the first process we used. All right, so if you do the same thing here, remember it is positive here. If you pick it to the other side of the equation, it's going to give your x, sorry, my x as 8, and then plus 3 crossing over becomes negative 3. Therefore, my x is 8 minus 3, which is still equal to 5. So now this particular approach makes it easier for you to solve this problem without adding, subtracting, and all of that. But if it is multiplication and division, you just divide both sides. If it's multiplication, you use the opposite, which is dividing both sides. If it is a division, you multiply both sides, or you do what we call cross multiplication. Of course, we are going to see more example. I am allowing you to do example 3 and 4, and then let me have your solution in the comment section. So we go to the next slide. Here we have that you can see now the operation now is multiplication for number 3. To find our x here, all we need to do is to divide both sides by 3, because 3 is the only thing joining our x, and it is joining our x by multiplication, and the opposite of multiplication is division. And so this 3 will take away this 3. Our x is alone now. Therefore, our x is equal to 18 by 3 will simply give us 6. And of course, if you check it, when you multiply 3 by 6 as your x, you will definitely get 18. So over to number 6 here, the same thing is applicable. I will also allow you to do this, or quickly, if you divide both sides by 1.4, you divide here by 1.4, this will quickly take away this, and so your k becomes 4.2 all over 1.4, and that is equal to 3. And of course, 1.4 times 3 will definitely give you 4.2. And so what about example 7? Now, see what happens here. In this case, there is a division. So our V is divided by 5. In other words, they are asking us, what number will you divide by 5 to get 9? All right, so what do you do there? Simply now do the opposite of division, which is multiplication. So to take away this 5, I will multiply both sides. So on this side, you will now multiply 9 by 5. And of course, what will happen immediately is that your 5 will take away this 5, and your V becomes 9 times 5, which is 45. Okay, so, and that's a way to solve this and to get your solution. All right, now what about the example 8? I'm going to do example 8 in two ways. The first is now I want to get my U, and I have a division here. So, and if I want to multiply, I would need to multiply by uh, the thing that is dividing, which is U, and I don't want that, which is also another way actually. So what do I do first? The first method I want to use, remember that 8 is the same thing as 8 over 1. So I can choose to take the reciprocal of both sides. Now, what is reciprocal? Reciprocal means just turn it upside down, the inverse. So if I do that, I am going to get on the left hand side will be u over 24, and on the right hand side will be 1 over 8. After achieving that, I can now multiply both sides by this number, which is now the denominator. So I will now have u, and what's going to happen here, of course, 24 will take away this. So your u alone is now equal to 8 into 24 is going to give us 3, and 1 times 3 is actually equal to 3. So that's one way to do this. Of course, you can see 24 all over u, which is now 3, will definitely give us 8. So this is correct. So that's one way to do that. And then another way is to do what we call cross multiplication. And so I can actually have my 24 all over u equal to that 8, still make it over 1. And when that happens, if I cross multiply, now that's this way, let the number, you do a diagonal multiplication. That's what we call cross multiplication. And so when my u multiplies 8, I will get 8u, and that is equal to 24 multiplying 1 is 24. And then at this point, I can now apply the method in 6 and 5. That's division. So I can now divide both sides by 8, and so this will cancel this, and my u will now be equal to 3. There are two methods you can use here to actually get your solution for this problem. And so now in example 9 and 10, you can see that we are now moving further into now when we have a combination of addition, multiplication, even subtraction and division and all of that. It is possible to have a combination of all of these in one equation, and you are asked to solve. Like what we have here, there's a combination of multiplication. 7 is multiplying x here, and there's a subtraction of 9. So how do you do that? All you need to do is take the steps one after another. So the first thing is to take away this 9 here, and to take it away, like I said, you can just bundle the whole of the minus 9 to the other side of the equation, and you will be left with 7x equal to 40 plus 9, because it is negative on the left hand side. So when it goes over to the right hand side, it becomes positive. So that gives us 7x is equal to 49. Okay, so and then at this point we can just quickly divide both sides by 7, and then my x will be alone, and that will be equal to what? 7. Of course, 49 over 7 is equal to 7. Okay, if you do the same here, now watch the example 10, you would see that our example 10 has x on both sides, and a number with numbers without x on both sides as well. So what do you do? Simply do what we call collection of like terms. So I collect like terms. And what do we mean by like terms? The ones that have x should go together to one side, and the ones that don't have x should go to one side. That's exactly what we are going to do here. So, and how is that going to happen? Our x, 2x will come over here, and then 4 alone will go over to this side. So, and in doing that, ensure that you write the one that is on this side first. So 5x is already here, so I will write it first, and then 2x is coming. Now, meanwhile, you should also check the sign of whichever one you are moving. Now, this 2x here is actually positive. If it were negative, there will be a negative sign in front. So whenever you have a number without a sign or an expression without a sign, it is always positive. So if I move the positive 2x to this side, it becomes negative 2x, and that's my equal sign. And then on the right hand side, I have positive 11, and because I'm writing it first, I can remove the positive sign. And then when this negative 4 now joins it, it becomes positive 4. Okay, so on this side, 5x minus 2x will then give us 3x. Remember, this subtraction is you use the coefficient. 5 will just subtract 2, you have 3, then you just bring down the variable, which is x, and that's equal to 11 plus 4 is 15. So at this point, you can easily do your division. So 3 is dividing both sides because we want x to be alone. Therefore, our x here is equal to 15 all over 3 is equal to 5. And that's the solution to this problem. And if you substitute, you do a check, put 5 into this equation. 5 times 5 is 25. You subtract 4 from it, you will get 21. On the left or right hand side, 5 times 2 is 10, and 10 plus 11 will also give you 25. So you see that the statement is true if you put your x as 5. And so that's the solution. And this is where I will end it. In the next video, we will push it further with more examples on simple equations. So if you have not yet subscribed to our YouTube channel, kindly do so. It helps our algorithm and the growth of this channel.